Okay, differential equations. Like I said, basically you're given a differential or derivative. You're working backwards to find a general solution. Sometimes it's a little more complicated than you think of just taking an integral. Okay, so here's an example of a differential. Okay, you might be given something like that. Notice how, here's one key for this one. Notice that it's dt on the bottom and t on the right side, correct? Okay, that's key in this. So we can rewrite it as dy equals t dt. You've done that before in u substitution. Now we can actually integrate both sides to find the general solution. So the integral of dy is y, right? And the integral of t, you're missing something. Let's see, thank you. Okay, that would be the general solution. Okay, that one you can build from your previous knowledge. There are a few that are a little bit more complicated that we just have a little formula for. So instead of writing y prime. Okay, this is the same as writing dy dx, right? Here's the difference here. Notice that it's dy on the top and y on the right. Okay, now we can't do what we did above because that differential has y and dy with it. Okay, dy is on the top and y is on the right. We can't mess with it like we did this one where dt was on the bottom and t was on the right. Okay. There's a general solution for this. That you just have to kind of know. Okay. Yeah, it's a constant, any number. Tomorrow we're going to go over how to figure that number out. Okay. No, it's any number. It could be 2, it could be pi, it could be -5. Okay. These are both what we call first order. Okay. Because it's we're not going to worry about anything else other than first order today. Okay. That just means it's one derivative. It's y prime or it's dy dx. Okay. First order. It's a new. If you wanted a second order, okay, that would be second order. Y double prime. Right, it goes with the degree of the differential. Okay. All right. There's one other word that we're going to have to learn, separable. And I'm just going to show you that through the example that I'm going to put down here. And this is the only one we're going to do today. So we're going to show that. Yeah, we're going to show that that differential, first order differential, is separable.
What is after that? Minus?
Yeah, y dy dx minus x equals 0. This is why I don't write my own math in pen. There's a lot of eraser marks on my paper. Huh? Yeah, we're not going to worry about that. But. Okay, so basically, isolate dy dx. Okay, so add x. Right? And then divide by y. And then you need to make it a product. How can I make that a product? Yeah. If this is a product, it means it's separable. What that means is you can separate the variables. From here, here's another. If I take the dx and move it over, the variables are now separated, right? So from this step here, I can show that it's separable as well. This is what you'll need for the general solution. All right.
Why do we want separable?
If it's separable, it's a very easy differential to solve.
How do you determine as a matter of fact that it's separable? Does it just look separated, or?
Because this is a product.
Okay.
If that's a product on the right side, you know it's separable.
Okay.
If it's not, if it's a add or subtract, it's not separable.
And what about the y dy and the x dx? That's your
That is another way to show that it's separable. You've separated each variable on each side. Okay. Okay, for our general solution, we need to use that. Now we can integrate